Welcome to Predict a Projectile Landing Point. What we're going to do in this video is actually implement our method call. Don't look at that for too long because it's the solution to your challenge, and find that the logs will actually tell us where we should be aiming our barrel as unit vectors, which is pretty cool. Can't we just work out where to point this barrel already, I hear you cry? Well, I'm glad you asked, because yes, it is time to actually implement this method. So let's take a quick look at this. You've looked at this as your homework. It's time to actually implement this code now. I think I'm actually going to keep it on the screen on the left here and see if I can find some room for Visual Studio on the right hand side. I'll close my Solution Explorer, customize my workspace so that it works for me. Okay, cool. I don't even need these line numbers, but I think I'll try and do this, squeezing them in. Can I just change the dividing point here? I can. Good old Windows is helping me out a little bit there. So I'll just get you set up with what we need at the beginning and the end, and then you can actually make the method call yourself as the challenge. Go ahead, do the whole lot if you think you know what I'm going to do. But for everybody else, we're going to firstly protect our barrel pointer, remember. So if we don't have a barrel, then what do we want to do? We want to get out of here. We return. Return what? Well, void, so nothing. Fantastic. So that's protecting that barrel reference. What else do we need? Well, we're going to need a start location. In fact, let's just go through this in order. We're going to need a world context object. Well, this will do. Literally, the word this will do, because our tank aiming component is sufficient as that world context. So there's a hint for you for the challenge. Now, the toss velocity. Do we have the toss velocity yet? Well, it's an out parameter. It's actually the toss velocity we're going to get out of this thing. So you're going to need to make room for an out parameter. I'm going to call that out parameter launch velocity. So let me do that bit for you. S vector out, I'm going to call it out launch velocity, just to mark it as an out parameter a different way. Unreal does this inside the engine. Okay, what else are we going to need? We're going to need the start location. So let me just help you a little bit with the start location, which is this guy here. That's going to be a F vector, of course. And it's going to be called start location, just to keep things simple. Now, we're going to start on where the barrel is. But what part of the barrel? If we go to the barrel and use a arrow operator, because it's a pointer, then we can ask ourselves, well, what can we do? We could try and get location, and my autofill gives me the following. Get component location. Well, it's not a component. It is a component. But we can do better than that. We don't want to get a custom location, but we can do even better and get a socket location if we want to. So either get component location or get socket location. I'm going to roll with get socket location, and we're going to make a socket first over on the barrel. So you go to the tank FBX barrel, static mesh, open it up, add yourself a socket. Because of the bug, we move the socket to where we want the projectile to launch from first, say here. Then we give it a rename to projectile. Because it's referenced by string, let's copy that into the paste buffer so that we've got it ready. So now we have a place that we can adjust on the barrel. As long as we save that barrel, then we're going to be able to find that socket from code. And the way we do that is we use the get socket location method. What does it take as a parameter? It takes an fname for the socket in question. So we can construct that fname by going fname, open brackets, and then as a string, the word projectile. And if you read the documentation of that method, it'll tell you that it'll go and try and find a socket called projectile, and if it can't find one, it'll just return the location of the barrel. So it fails over nicely. I like that. That's always good. So then we're going to make our function call. So make also the calculate the out launch velocity, and you're going to do that bit, given that I've set you up properly. And then what we're going to do at the end after that is we're going to turn that into a unit vector using the .getSafe normal. So I want you to create a auto desired or aim direction, let's call it. And that's going to be equal to whatever this out launch velocity is, which, remember from the previous slides, if I go back, will be this guy here, the big green arrow. I want you to convert it into that little white arrow, and the way that we do that is using the .getSafe normal method, which you can go read about if you like, but that's just going to turn it into a unit vector. All right, so now you have an aim direction, and we can say aiming at. You can see what I'm doing here. I'm just setting up the outside of this thing for you. Let's just maximize this window for now. Aiming at, aim direction is coming out as a vector, so I'm going to say star aim direction dot to string. And then if the aim direction is actually a f vector, like we hope it would be after this, it will right now, by the way, be an empty f vector. In fact, let's just test it compiles before I even put you into the challenge. While it's compiling, I'll show you the code I've written. It's just here. Nothing's going on because we set a launch velocity. We don't bother to initialize it because we're about to use it as an out parameter. And this, because it'll initialize by default to 0, we should end up getting aiming at 0, 0, 0. Aiming at 0, 0, 0. Perfect. So you are now ready for your challenge. What I want you to do is make the method call. Sounds easy enough, but you need to make sure you read the docs properly. So fast forward to it. And here we go. Use suggest projectile velocity. That's the method to use. We've talked about that. Use out launch velocity.getSafeNormal. I've done that bit for you. And then log out the required aim direction. I've even set up the logging. So all I need you to do is write the method call for suggest projectile velocity properly and see if you can get it working. Go ahead, pause the video, give it 5-10 minutes if you need to, and I'll see you in a moment. Okay, welcome back. So this is where I'm going to split my screen again because I do think it's helpful to have the method details on the left-hand side here. And let's see if we can make this method call. So, firstly, I want a pattern where I say if we successfully calculate the launch velocity. So if we calculate the launch velocity, then I want to go ahead and print this stuff out here. So just tab these in. Otherwise, we're going to do nothing. So if no solution found, do nothing. And that's because this thing, this suggest projectile velocity, returns a Boolean. And if it can't succeed, it says false. Okay, so this pattern here is going to allow us to only log if we get a result. So then, if you're going to do that all in one, how do we lay it out? Well, we've done this very recently. So let's just go ahead and get on with it. And it's just a bit of weird indentation, which I think probably ends up with the cleanest code that we can get. So I've taken too much stuff. If you gameplay static suggest launch projectile velocity like so. Going to get rid of the comments. So there is the beginning of our function call, right? At the end of that. So what we're going to do is open the brackets, let's say here, or on this line. And then we're going to close the brackets somewhere down the bottom. So it's in here now that we're going to make the method call and pass in all of the parameters. So I said that this was going to be the context from the left screen. The world context was just going to be a reference to the actual tank aiming component. The toss velocity, what was that going to be? Well, that's going to be the out parameter, this out launch velocity. That's what we're going to get out of this thing. So there's the toss velocity. Let me just tighten this stuff up a little bit. Hopefully you can see what I'm doing with the indentation here. Now, have I mismatched my brackets? I have. I need another closing bracket. And I'm going to push all these parameters in by one indentation. There you go. It's a bit weird, maybe a bit clearer like that. So, yep, I think that's working. So out launch velocity, start location. So what is the start location? Well, we've defined it above. Then what comes next? The end location. Well, the end location is the hit location. That's where we want it to end up. Toss speed. Well, that's the launch speed that we've already given ourselves. Fantastic. The high arc. We don't want to go by the high arc, so we say false. Then the collision radius. How much variability do we want on it? 0. I'm going to choose because we want to aim precisely. The override gravity, no, we're not going to do that. And the final thing, which is a little trickier, is that you need to decide whether we're going to trace or not, whether we're going to debug trace. So I'm not going to bother, but I am just going to find the name of this enumerator by copying it without clicking on it, which is harder than it sounds. There, and then I'm going to go colon, colon to get the things, and I'm going to say do not trace. And that should be it. I think, yeah, the bracket matching is working now, and that is my code. If this succeeds, print this, otherwise do nothing. I hope that makes sense. Now let's go ahead and see if it compiles. All very well, the code making sense. I'll leave it on the screen while it compiles. I think that's a helpful general habit for you guys to follow. Please tell me in the one of our forums or on the Facebook group if you find that helpful, or even in the Q&A on Udemy, wherever you like. Okay, how are we doing? That worked. Aiming at, and now it's telling us, if I wanted to hit this world space location, where would I need to aim? 3 of them are staying consistent, but look at this guy. This looks feasible. it's saying that in order to hit that mountain, I would need to aim at y equals 1-ish, which is to the right. X equals not very far forward. In fact, you'll see as I go forward and backwards of the exactly right-hand direction, i.e. the exactly positive y direction, that x goes either side of 0. I'm looking at the line that's changing here, of course, in the logs. And then the z is depending on how high I'm aiming. So let's just try aiming at the sky. What happens? Well, we don't know for sure because we're not logging the tank name. So we'd better just pop in here the tank name as well. So we're just going to go auto tank name equals get owner, get name. May as well do all of this, toString. Okay, and then I can just put the tank name in and just pop it right in here. Star tank name, comma. That's great. Let's just recompile that because the information I'm getting right now is I don't know which tank, whether my tank, when I'm aiming at the sky, is failing to find a solution. I'd be guessing if I tried to look at those numbers. So I've done a boo-boo. ToString is not a member of fstring. Oh, of course, the name is already a string. Silly me. Okay. Easy to do, though. So this is the code I'm ending up with. I'm just getting a tank name here and just passing it in as a second parameter so that when I do my check here, I can be sure that my tank, now before we do that, let's see what my tank is. Let's depossess, go to the world outliner. Which one is my tank? It is BPC 38. Okay, so let's repossess. So we don't really know for sure that that's working perfectly, but I think we can move on and start actually firing a projectile. That's going to give us a much better bit of visual feedback than trying to stare at these numbers and work out if they're giving us what we want. So well done on getting this far. I'll leave the code on the screen for you. Hopefully it makes sense how we made this method call and what it's doing. And now we actually have something that we can use to this aim direction here to actually point the barrel.